Good evening everyone. This is Shambhavi, your physics master teacher. Welcome to VEDANTU Karnataka. How are you all? Hope my voice and video is clear. So just let me know if it is fine at your end. So let me also check. Yes, I think it's fine here. Hope it is fine there also. Good evening to everyone. If you are there, kindly give me a quick response and mark your attendance once you join. Yes. Hello Sumit. Hello Rakshita. Hello Sindhu. Voice not audible. What about others? I think it's fine here. Check once. Yes, what about others? Hope voice is clear. Could you just respond? Quick response, please. Okay, fine. Yeah, fine. Okay, thank you. Thank you for your response. So in today's KCET session, we are going to start with the new chapter, that is motion in a plane. Okay, so as you know, in this session what we will do, so initially we'll talk a little bit about the concepts in that particular chapter, and then we'll go for some practice questions and PYQs both. Okay, so that is the plan for this particular batch. Okay, so with minimum concept recap, we will try to solve as many problems even from PYQs and some practice questions as well. Okay, so I'll be starting up with motion in a plane. I think you are almost done with motion in a straight line from your Catherine ma'am. I hope so. So madam is doing on that. Yes. Okay. So let us reframe ourselves to stick to the academic discussion in the chat box. Yes, Anita, hello. Good evening, good evening. Hope all of you are back from your colleges, and we'll quickly start with our session of today. So today what I have planned is we'll be covering the basic vectors knowledge that is required for this particular chapter. Okay, so motion in a plane means you had to learn little bit of vector mathematics, which is evident in order to go ahead with solving problems when you are doing with it might be a projectile motion or a circular motion. So what we will do is we'll discuss little bit about scalars and vectors, and then we will go for addition and subtractions of vectors, graphical method as well as analytical method, and then we have resolution of vectors or resolving of vectors into component, and then we'll take up problems on these particular topics. Okay, so this will be the goal for today. So I think we can quickly start with this session. So just give me a thumbs up if you are there, and also mark your attendance, and you can give me a thumbs up in the chat box so that I'll get to know that I can go ahead. Law of vector addition. Yeah, definitely we are going to discuss that. Law of vector addition we will discuss. Okay. Hello. If I have missed some names, so hello to everyone and good evening everyone. Okay. So yeah, we'll quickly start. So you know that physical quantities can be divided into two particular categories, that is scalars and vectors. Okay, so whereas scalars are those quantities which are having only magnitude, whereas vectors are those which are having magnitude, direction, and also you should specify one additional word, that is it should obey vector law of addition, okay, or it should obey laws of vector algebra. Okay, you can say vector addition principle it should obey or it should follow, or you can say vector algebra it should follow. Okay, so because I think you might be having little idea about vector addition, subtraction, how we do, right? If I say there is a 5 kg mass and 10 kg mass, and if I tell you to add, you can directly add like 15 kg. But when it comes to vectors, it follows a certain different way of addition, it might be, or a subtraction, it may be, even in multiplication, right? So there is a slight difference because the angle between the vectors matters a lot. In other words, that is nothing but the direction. Okay, direction plays a very important role. So depending on the direction, yeah, we had to follow certain rules to add or subtract or to do the multiplication. Okay, so it should follow vector addition principle. Okay, and to name some scalar quantities, you can say like mass, time, distance, and so on. For vectors, we can say like displacement, velocity, acceleration. Okay, so we can name many vector quantities like force. Okay, so we can mention many vector quantities as well, whichever the quantities having magnitude and direction and which follows the vector addition principle, we call them as velocity. So there is one particular quantity which usually you may get confused, that is with respect to electric current. So you may feel like electric current is a scalar or a vector, because you may feel it like a vector quantity because current has a direction. Yes or no? Electric current has a direction, but while adding the current, we do not follow any vector addition principle. We just follow the normal algebraic addition. So electric current is a scalar quantity. Please remember, current is a scalar quantity, though it has a direction. We specify the direction of the current, right? It goes from this point to this point like that. And if you are already in second PUC, you might be dealing with current electricity chapter already, and you can you have observed that you mark the direction of the currents, right, in the circuit. So it doesn't mean that just because direction is there, it need not to be a vector. So it should also follow the vector addition principle. Okay, so this is about scalars and vectors. So now we'll just move on to in detail about vectors. Yeah, so any doubts you can just ask in the chat box. Okay, so how to represent a vector? So in order to represent a vector, okay, so we need to have a directed line segment. So what do you mean by directed line segment? So we will represent the magnitude of the vector by a line. The length of the line represents the magnitude of the vector, and we put an arrow to show the direction of the vector. Okay, so this arrow will tell us the direction of the vector. Is that fine? And if I say this is some vector AB, okay, let us say this is some AB vector. Okay, so this point represents the tail of the vector, whereas this arrow point we call it as head of the vector. Okay, so the starting point of the vector we call it as tail, and the arrow part we call it as head of the vector. And if you want to represent it, so with the variable notation, so it is like AB vector, or if I name this itself as something like R, so how do I say R vector? So variable on top of that an arrow represents the any vector. Okay, if you are representing the vector with the notations, not geometrically. So this is a graphical way or geometric way, right? In a diagrammatic way we are representing. So if you want to represent the vector with the with their notations, so the notation what we follow, either write the variable there, a, b, c, whatever it is given, on top of that put an arrow. So that is how you represent. And some books may follow bold alphabets, bold letters. Okay, yeah, if I just bold this R without the arrow also, yeah, if you just have a letter or some variables like a, b, whatever it is, so without arrow, but if those are bold letters, it is representing the vector. Is that fine? Any doubt? If you have doubt, please ask in the chat box. This is how you represent a vector. Okay, so vector, if you want to represent it diagrammatically, how do you represent? So the the directed line segment with the length being equal to the magnitude, and the arrow gives us the direction. Okay, so this length will be giving us the magnitude of the vector. Okay, is that fine? Any doubts? Yes, Rakshita, do you have any doubt? Okay, so moving to next part of the discussion. So some types of vectors or some definitions which we will be using in vector algebra. The essential thing you should know is a unit vector. So what is a unit vector? So a unit vector is the one which has a magnitude equals to 1 itself, or unity. Unity andre ಏನು ಅರ್ಥ? It is nothing but 1. Unit andre ಏನು? 1 ಅಂತ, correct? So it has a magnitude equal to 1. Okay, so usually unit vectors are represented by cap notation. Okay, for example, if I have a vector like a vector, so ಇದರ ಯೂನಿಟ್ ವೆಕ್ಟರ್ ನ ಹೆಂಗ್ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀರಾ? a cap represent unit vector. Okay, a cap represents unit vector. And also, if I just had to tell you what and while representing, what are all, or how can we differentiate between which part is representing a vector, direction, and which part is representing us its magnitude. For example, if I have a vector like a, or some force vector, let us say, okay, we have a force vector, okay, of some magnitude like 5. There is a 5 Newton force and it is acting in some particular direction. Let us say something like n cap. Okay, so where this n cap is the unit vector which is giving us the direction of the force. Okay, so later we will come to know that in our Cartesian coordinate axis there is a standard 3 unit vectors we discuss. Okay, so which are those? So let me just write. Okay, I'll just add a page there itself and I'll just write there. So in Cartesian notation, so Cartesian notation andre eno, or Cartesian coordinate axis andre eno, so it's like our 3 orthogonal or 3 mutually perpendicular axis, which you usually call it as x axis, y axis and z axis. Corresponding to these 3 directions, we will be having 3 unit vectors, that is I cap, j cap and k cap. Okay, So I cap, j cap and k cap. Is that fine? So I cap is unit vector along x-axis. And j cap means what? Unit vector along y-axis. And k cap is unit vector along z-axis. Okay, so these are the three standard unit vectors which we will be using. Okay, any doubts? Yeah, so many messages are there, I might miss the actual academic doubts. Please reframe ourselves to discuss academic related in the chat. Okay, so now the next point is, if I say there is a velocity, okay, some velocity I want to represent, velocity of 2 meter per second along x-axis, if I want to represent this. So how do I do? So I can say some velocity v vector is equals to magnitude is 2 meter per second and its direction is x-axis means what? I can just put a unit vector along x-axis, that is I cap. So 2 I cap is the representation for velocity vector with a magnitude of 2 meter per second and I cap is representing the direction of the vector. Okay, hope it is clear. Any doubt? So this, in this f vector is equals to phi n cap. This phi is representing the magnitude. Okay, whereas n cap gives the direction. That unit vector is used to specify the direction of the vector because its magnitude is anyway 1 and depending on I, j and k, you will get the direction of the vector. Okay, so the other important vector which we will be using now and then is null vector or a zero vector. Again, the name itself is telling us it's the vector with a magnitude equal to 0. Okay, it's a vector with a magnitude equals to 0. We call that as null vector or zero vector. So we can just represent like, with the O on top of that vector notation. Okay, so that is how a null vector is represented. For example, we have some 5 Newton force in plus x-axis and some minus 5 Newton force or 5 Newton force along negative x-axis. Aga net force ಏನಾಗುತ್ತೆ 0 ಆಗುತ್ತೆ, correct? Yeah, equal and opposite force ಇರೋದ್ರಿಂದ net force 0 ಆಗುತ್ತೆ. So that is an example for null vector. Okay, and our origin of the orthogonal coordinate system, the origin of the coordinate system is also a null vector. Okay, just to give you an example for null vector. So next is negative of a vector. So the next is negative of a vector. A vector having same magnitude but opposite in direction to the given vector is called a negative of a vector. For example, I have my A vector in this direction. So negative of A vector andre enagirbeku, magnitude same irbeku. Okay, the length of this line segment same irutte but direction ulta irutte. Okay, so that we call it as a negative of a vector. So direction reverse irutte but magnitude same idre adanna navu negative vector anta karitivi. Okay, so any doubts? Any doubts? Please respond, or if you are just following, please give me a thumbs up in the chat. Quick response, please. Yeah. So next is collinear vectors. Collinear vector andrenu, the vectors which are along the same line are called as collinear vector. So a vector along the same line irutte. Okay, they are not in some way like one vector this direction, one vector this direction. So this is going to be a coplanar, same planar ide but along the same line illa. So that is one type of vectors which we will be discussing, collinear vector. Next is coplanar vector. Okay, so vectors lying in the same plane. 3 or more vectors which are lying in the same plane are called as coplanar vectors. Nimge erade vector kotre, they are always going to be coplanar. Okay, so coplanar vectors andre they are lying in the same plane. The next one is equal vectors. Yavaga eradu vector na equal vector anta karibodu. So yavaga, so equal vectors andre two vectors are said to be equal vectors when they have equal magnitude and same direction. So ಎರಡು ವೆಕ್ಟರ್ ನಾವು ಈಕ್ವಲ್ ವೆಕ್ಟರ್ ಅಂತ ಕರಿಬೇಕಂದ್ರೆ ಅದರ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡು ಸೇಮ್ ಇರಬೇಕು, ಡೈರೆಕ್ಷನ್ ಸೇಮ್ ಇರಬೇಕು. ದೆನ್ ಓನ್ಲಿ ವಿ ಕಾಲ್ ದಮ್ ಆಸ್ ಈಕ್ವಲ್ ವೆಕ್ಟರ್ಸ್. Yes, thanks for your responses. Mathematics will be going to start soon. Okay. Yes, we do know the concern, and soon it is going to be started. Okay. Yes. Yes, Dharmaraj. Sorry, what is that? Nagamma Dharmaraj, right? Thanks for your response, and Rakshita as well. Yes, hope you know that there is an offline center at Bangalore. Yes, Rakshita, your question is, do we have Vedantu offline classes? Yeah, definitely it is there in JP Nagar. Okay, if you are asking in Karnataka, one center is there, that is in Bangalore, JP Nagar. Okay, and if you are from outside of Karnataka, there are many centers are there which I can give you at the end. Yeah, as of now in Bangalore we have one offline center. Okay, yeah. So the next thing is, I mean, just know all these types of vectors, because in some problem they suddenly they may use some words which should not to confuse you. So I'm giving you all this. So polar vector is the broad classification of the vectors. Okay, all the vectors are classified either into polar vectors or axial vector. So polar vector andre, they are like, you will be knowing at what point the vector is acting or at what point the vector is starting. It's just like displacement, velocity, acceleration avella. Okay, so yava point alli vector start agtide athwa at what point the vector is acting annೋದು ನಿಮಗೆ ಗೊತ್ತಿದ್ರೆ ಅದನ್ನ ನಾವು polar vectors ಅಂತ ಕರಿತೀವಿ. Okay, and also you can say like vectors whose direction is along the direction of motion of a particle. Okay, so I mean, if the particle is moving in this direction, so ee vector in a directions enirutte along the motion of the particle, athwa it is along, it mean it is in this direction or opposite to it, ade line alli irutte. Okay, so they are called as polar vector. Innondu classification eno axial vectors. So axial vector andre idara direction will be always along the axis of rotation irutte. Nimge rotational motion chapter baruttalla, alli use maduva few vectors are going to be axial vector, like angular momentum, angular velocity, torque. Okay, they are going to be axial vector. Okay, alli enagirutte, direction will be along the axis of rotation. Okay, okay. Yes, Rakshita, you are in first PUC or second PUC? May I know? Yes, I got to know that you are asking about whether, yeah, you are in first PUC, right? Once you have to check with the PU board notification regarding if the admission is still allowed, because there will be one deadline, no? Before that your admission should have been done. I think it is still possible. Even I'll check and get back to you in the next class as well. Okay. I hope the still admissions are going on. I'll just once check and get back to you for first PUC, right? Okay. Hope that is fine with Rakshita. So this is about the different types of vectors and their definitions which we'll be using. Okay, so next coming to the addition of vectors. Yes. Okay. So addition of vector. Again, ಇಲ್ಲಿ additionally ಎರಡು type of addition ನಾವು mention ಮಾಡಬಹುದು. ಒಂದು graphical method, ಇನ್ನೊಂದು analytic method. Okay, analytical method and graphical method. ಸೊ ಈ ಗ್ರಾಫಿಕಲ್ ಮೆಥಡ್ ಎಲ್ಲ ಎರಡು ಇರುತ್ತೆ. ಯಾವುದು? ಒಂದು ಟ್ರಯಾಂಗಲ್ ಲಾ ಆಫ್ ವೆಕ್ಟರ್ ಅಡಿಷನ್, ಅನದರ್ ಒನ್ ಇಸ್ parallelogram law of vector addition. So first we'll see what is this triangle law of vector addition. So quickly we'll recollect. So if I have two vectors, so let me say something like A vector is there and somewhere here, okay, let me say something like this, B vector is here. So now what I should do is in this method, so I have to shift these two vectors so that the head of one vector coincides with the tail of the other vector. So let us say we are shifting them parallelly. So this is my A vector and somewhere in this direction we have our B vector. Okay, so illenagide, the tail of B vector is coinciding with the head of the A vector. So this is called as taking in the same order. So ಈಗ resultant ಏನಾಗಿರುತ್ತೆ, so it will be in the direction such that if I form a closed triangle by taking the third side in the reverse direction. Okay, let me just take this now. Yeah. So ಏನಾಗಿರುತ್ತೆ, yeah, if we take the third side of the triangle in the reverse order, that is going to give us the sum or the resultant of two vectors. So illenu A vector plus B vector will be equal to R vector. So illi observe ಮಾಡಬೇಕಾಗಿರೋದೇನು, so if you just see here the tails of the two vectors are coinciding, here the heads of the two vectors are coinciding, here head of one vector is coinciding on the tail of the other vector. So this is like same order, taking in same order. Okay, so we are just going like this and then like this. But illi reverse order endrenu, so this vector is going like this, but this is taken in the reverse direction. Okay, yeah. So these 2 points representing reverse order. Third vector na reverse order al tagondre, both in terms of magnitude and direction, we get the resultant of the given two vectors A and B. Okay. Yes, hope all of you are following. If you have just joined to the session, please mark your attendance and also give me a thumbs up. You can also like the session if you are able to follow what we are discussing here. Okay, that gives us some motivation to go ahead. Okay, so now let us just quickly read out what exactly the statement of triangle law of vector addition says. If two vectors are represented by two sides of a triangle, okay, taken in the same order, this is very important, then the third side of the triangle taken in the reverse order is going to represent the resultant of the two vectors. Okay, so this is one method. The other method of, okay, yeah, here itself we can discuss, I feel, that is about the subtraction, because just with a slight modification we can use triangle law of vector addition for subtraction of vectors also. So subtraction of vectors andrenu, for example, I say like, we have A vector minus B vector ಮಾಡಬೇಕು ನಾನು subtraction andre, but this can be represented as A vector plus of minus b vector anta tagolbodu. Correct? Saying a minus b is nothing but equal to a plus of minus b vector anta tagolbodu. Correct? So that is what the subtraction. Illi minus b andrenu, it is the negative of b vector. Okay? So adanna illi represent madana. So ಏನು ಹೇಳ್ಬೋದು, let us say this is our a vector, and then let me say something like this as our b vector. Okay, so next step enagirutte, this is our a vector, this is the direction, and this is our b vector. So you have to shift the vectors parallelly so that head of one vector coincides with the tail of the other vector. That is how you do vector addition. So first we'll do that, then we'll go for subtraction. Okay, so again agide, so this is one vector that is parallelly shifted a vector, let me say, and also I have this parallelly shifted b vector. Okay, this is a vector, this is b vector. So ಈಗ a plus b ಬೇಕು ಅಂದ್ರೆ ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ ಏನ್ ಮಾಡಬೇಕು ಅಂತ. So I am taking the third vector in the reverse direction. Correct? So take the third vector in the reverse direction. And we know that this is going to be r vector, which is a plus b vector. Correct? Hope you are following. ಈಗ ನಮಗೆ a minus b ಬೇಕು, ಅದಕ್ಕೆ ಏನು ಮಾಡಬೇಕು? So it is like I should take minus b vector. So this is b vector. Correct? So minus b vector ಎಲ್ಲಿರುತ್ತೆ? Yeah, minus b vector ಎಲ್ಲಿ draw ಮಾಡಬಹುದು? So same magnitude but in the opposite direction. Correct? So this is my minus b vector. ಈಗ a minus b ಮಾಡೋದ್ರ ಬದಲು a plus of minus b ಮಾಡ್ತಾ ಇದೀವಿ. So this is arrow. Okay, now in accordance with the triangular law of vector addition, ಏನಾಗುತ್ತೆ, I can say that the third side of the triangle taken in the reverse direction. Okay, so third side of the triangle taken in the reverse direction is going to give us the resultant of the two vectors. So I call this as something like r dash vector, which is equals to a vector minus b vector. Okay, hope it is clear. So two vectors taken in the same direction, then take the third vector in the reverse direction. So that is going to give you the resultant of the two vector. And nimge subtraction ಮಾಡಬೇಕು ಅಂದ್ರೆ ಏನು ಬೇಕು? So you have to take the negative of the second vector. Okay, so it's so simple that you have to take the negative of the second vector. Okay, hope it is fine. Any doubt? Please let me know if you have some doubts. Okay, yeah, I will avoid red. Yeah, sorry. Hope with it's fine with yellow and light blue, right? Red will not look good. Correct. I usually avoid. Today I took it. I'm sorry. Yeah, how much we have used red? Okay. Yeah, here little bit, no? Okay, I'll just don't use in further. Hope it is. Yeah, okay. So the next thing is parallelogram law of vector addition. So ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ, we will take the given two vectors. Again, let us say we are given with two vectors, a vector and b vector, and theta be the angle between a vector and b vector. So ಈಗ ಏನು ಮಾಡೋಣ, we will just we'll try to represent them. Okay, so this is one vector, and let me say we will represent the given two vectors as the two adjacent sides of the parallelogram. That's very important. How are we representing? So we are representing them as two adjacent sides of the parallelogram. So this is A vector, this is B vector. In all your vector diagrams, you are supposed to mark the arrow. Okay, arrow bardilla andre board exam alli 100% marks kattagutte. Okay, so direction is very important. Neevu arrow hakilla andre adu vector anta agodilla, some general line anta agutte. So you had to put arrows in all your vector diagrams. Okay, yeah. So the angle between A and B ಎಷ್ಟು ತಗೊಂಡಿದ್ದೀವಿ, theta ಅಂತ ತಗೊಂಡಿದ್ದೀವಿ. Okay, so this is theta. ಈಗ resultant of these two vectors ಎಲ್ಲಿರುತ್ತೆ? So now if I just complete this parallelogram, okay, so ಏನು ಮಾಡೋಣ, we'll just complete this parallelogram. So parallelogram ಅಂದ್ರೆ four side ಇರುತ್ತೆ with opposite sides being parallel to each other, right? So something like this. Yeah, something like this it looks. And now if I draw the diagonal which passes through the intersection of these two, okay, yeah, this one I'll take the normal line. Okay, so this will be representing the resultant of the two vectors. So this is our R vector. ಏನಾಗಿರುತ್ತೆ, the diagonal which passes through the intersection of these two points, correct? So ಈ diagonal ತಗೊಂಡಿಲ್ಲ ನಾವು, correct? ಇಲ್ಲೊಂದು diagonal ಬರಿಬಹುದು, ಅದಲ್ಲ. ಯಾವ diagonal will be representing the resultant of the two vectors? The diagonal which passes through the intersection of these two vectors A and B, ಅದರ starting point, right? So here we have the tails of the two vectors are coinciding. Okay, so that will be representing the resultant of the two vectors. ಇಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, the length of this diagonal gives the magnitude of the resultant and the arrow, that is the direction. Okay, so this will also give us the direction of the resultant ಆಗಿರುತ್ತೆ. So we usually take this angle as alpha. Okay, where alpha is the angle between A vector and R vector. So now I think we can quickly have a look about the statement of the parallelogram law of vector addition. Two vectors acting at a point. So ಇಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, you had to understand that the tails of the two vectors are coinciding. Triangular law ಅಲ್ಲಿ ಹಂಗ್ ಮಾಡಿರ್ಲಿಲ್ಲ. So one head, one tail taking in the same order ತಗೊಂಡಿದ್ವಿ. ಬಟ್ ಇಲ್ಲಿ ಎರಡು ವೆಕ್ಟರು ಸೇಮ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಆಕ್ಟ್ ಆಗ್ತಿರ್ಬೇಕು ಅಂತ ತಗೊಂಡಿದ್ವಿ. ಓಕೆ, ಸೊ are represented in magnitude and direction by two adjacent sides of the parallelogram. Okay, adjacent sides of the parallelogram such that those two adjacent sides are drawn from this particular point. Then their resultant is represented by the diagonal of the parallelogram drawn from the same point. Okay, so diagonal in the you will get the resultant of the two vectors. Okay, is that fine? Any doubts? If any doubts, feel free to ask in the chat box. You can also give me a thumbs up so that I can go ahead. You can quickly give me a thumbs up if you're following. You can like this session if you're following as well. Okay, so now as I said, in the graphical method we have two way of vector addition. One is triangular law and the other one is parallelogram law of vector addition. So now just by using parallelogram law of vector addition or triangular law of vector addition, we can end up with an analytical method or analytical way of adding the two vectors. That means if I know the values of magnitudes of A, B and theta, I can actually able to find out the magnitude of the resultant vector and also the direction of the resultant vector. Okay, so illi this are representing the vectors A and B. Okay, so they are just using the bold notation. So this is our resultant R. Okay, so now lenu by parallelogram law of factorization, if you observe, you can clearly tell that a vector plus b vector must be equal to r vector. A vector plus b vector must be equal to r vector. So illi, if this is b vector, the length of this sp line will also be equal to b ne agirutte. Okay, ee component enagirutte, illi theta ide. Okay, PNS is a right angle triangle. So illi PN is the theta attached side. Allige this will comes out to be b cos theta component agirutte. This will comes out to be b sin theta component agirutte. Opposite side. Okay, so just if you write the sin theta and cos theta ratio for PNS triangle, you get to know that PN will be equal to b cos theta and SN will be equal to b sin theta ಆಗಿರುತ್ತೆ. So ಈಗ ಪೈಥಾಗರಸ್ ಥಿಯರಮ್ ನ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಫ್ರಮ್ ಟ್ರಯಾಂಗಲ್ ಯಾವುದು ONS, ಓಕೆ, ಬಿಗರ್ ಟ್ರಯಾಂಗಲ್ ತಗೊಳ್ಳಿ, ONS ಏನ್ ಬರಿಬಹುದು, we can say r square, which is the hypotenuse there, or it is like OS square will be equal to ON square plus SN square ಆಗಿರುತ್ತೆ. Okay, yeah, ON square plus SN square ಆಗಿರುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಏನ್ ಬರುತ್ತೆ, r square is equals to, ಸೊ ಇಲ್ಲಿ ON ಅಂದ್ರೆ OP plus PN ಅಂತ ಬರೀಬಹುದು. OP plus PN is nothing but ON. OP andre it is like the magnitude of A. So A plus B cos theta whole square plus B sin theta whole square anta baribodu. SN andre idina just A plus B whole square tara expand ಮಾಡಿ simplify ಮಾಡಿದ್ರೆ we get R square is equals to A square plus B square plus 2AB cos theta ಬರುತ್ತೆ. Or we want the magnitude of the resultant of 2 vector, which is going to be square root of A square plus B square plus 2AB cos theta ಆಗಿರುತ್ತೆ. Okay, so this is the expression for magnitude of the resultant of 2 vectors. Okay, ಏನಿದು magnitude of resultant of 2 vectors ಆಗಿರುತ್ತೆ. Any doubts? Please ask. And okay, let me just give you one more thing and then we will move on to special case. That is the direction also I should give. Okay, so later we will go to that. So I'll just add a page. So you know, direction of resultant. Okay, vector. So heng baritivi, let alpha be the angle between A vector and the resultant vector, A vector and R vector. Then tan alpha is given by B sin theta by A plus B cos theta. If you define alpha with A vector and R vector, you can write like tan alpha is equals to B sin theta by A plus B cos theta agate. Ade tara, if I just mark another angle here, okay, I say, let me take a different color. Let us see this one. So if this angle, I call it as beta. Okay, yeah, that is beta. Don't get confused with B. Okay, let us use some other notation. No, I'll use delta. Okay, so delta is the angle between B and R. Okay, let us say delta is the angle between B vector and R vector. So similar formula baribodu. that is tan beta is equals to ಇಲ್ಲಿ a sin theta ಆಗುತ್ತೆ divided by b plus a cos theta. Okay, so a sin theta by b plus a cos theta. Okay, so this is either you can get the value of tan alpha or tan beta, or the value of alpha and beta. That will give you the direction of the resultant vector. Okay, so magnitude one formula, direction ಗೆ ಒಂದು formula. Is that fine? So next is special case. ಒಂದೆರಡು ಇಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ, then again in problems also it will come. For example, if theta is equals to 0 degree, okay, theta andre a vector is parallel to b vector ಅಂತ ಅರ್ಥ. ಸೊ ಆಗ ರಿಸಲ್ಟೆಂಟ್ ಏನಾಗುತ್ತೆ, r is equals to root of a square plus b square plus 2ab cos theta. ಸೊ ಇಲ್ಲಿ theta ಅಂದ್ರೆ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು, cos 0 ಅಂತ ಡೈರೆಕ್ಟ್ ಆಗಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀನಿ. cos 0 ವ್ಯಾಲ್ಯೂ 1, ಕರೆಕ್ಟ್. ಸೊ ದಿಸ್ ವಿಲ್ ಗಿವ್ ಯು ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆಫ್ a square plus b square plus 2ab ಆಗುತ್ತೆ. Hope you are following everyone. Quickly give me a thumbs up in the chat box, or you can like the session so that I'll get to know. And then I can say resultant r is equals to, so what is this a square plus b square plus 2ab? So from high school you are learning this identity. It is nothing but a plus b whole square. So r will be equal to square root of a plus b whole square. Illi square root to square root cancel adre ಏನು ಉಳಿಯುತ್ತೆ ನಿಮಗೆ, simply like a plus b. So this is the maximum resultant. Okay, ಯಾವುದೇ ಎರಡು ವೆಕ್ಟರ್ ನ ಆಡ್ ಮಾಡಿದ್ರೆ irrespective of whatever might be the angle, the maximum ಎಷ್ಟಾಗಕ್ಕೆ ಸಾಧ್ಯ ಅಂದ್ರೆ different angles ತಗೊಂತ ಹೋದ್ರೆ the maximum possible value is simply equal to a plus b. Okay, so this is one case. Second case ತಗೊಂಡ್ರೆ, if theta is equals to 180 degree, that is anti-parallel. Okay, one vector ಈ ಕಡೆ ಇರುತ್ತೆ, ಇನ್ನೊಂದು vector direction ಹಿಂಗಿರುತ್ತೆ. Okay, so one vector in this way, the other vector in this way. I can say a vector and b vector. Angle between them ಎಷ್ಟು, 180 degree. ಈಗ ಸೇಮ್ ಫಾರ್ಮುಲಾ ಅಪ್ಲೈ ಮಾಡಿ ಏನ್ ಬರುತ್ತೆ ಹೇಳಿ, ಕ್ವಿಕ್ ಆಗಿ ಮಾಡಿ. When I'll do here, you will also try there. So ಏನು ಬರುತ್ತೆ, root of a square plus b square plus 2ab cos 180 degree. So cos 180 degree value is to -1. Okay, cos 180 value -1. So it is simply going to give me square root of a square plus b square minus 2ab ಆಗುತ್ತೆ. Okay, or ಇದನ್ನ further simplify ಮಾಡಿ ಬರೆದ್ರೆ ಏನು, r is equals to square root of a minus b whole square ಅಂತ ಬರಿಬಹುದು, because a square plus b square minus 2ab ಇದೆ. That is nothing but a minus b whole square. Again ಇಲ್ಲಿ square and square root cancel ಆದ್ರೆ we get r is equals to a minus b. This is the minimum possible value for the resultant of two vector. Okay, so when we add two vectors, range of resultant ಎಲ್ಲಿಂದ ಎಲ್ಲಿ ತನಕ ಇರುತ್ತೆ, a minus b to a plus b ಆಗಿರುತ್ತೆ, depending on the value of theta. So maximum when they are acting in the same direction or parallel vectors, or angle between them is 0, and if it is going to be minimum when they are anti-parallel vectors or angle between them is 180 degree. Okay, so one simple case ನಿಮಗೆ homework ಕೊಡ್ತೀನಿ. If theta is equals to 90 degree. Okay, please try it out. If theta is equals to 90 degree, resultant ಏನಾಗುತ್ತೆ ಟ್ರೈ ಮಾಡಿ. Okay, simple one step ಅಲ್ಲಿ ಬರುತ್ತೆ, that you can do on your own. Okay, so the next is resolution of vectors into rectangular component. So ಇದನ್ನು ಕ್ವಿಕ್ ಆಗಿ ಡಿಸ್ಕಸ್ ಮಾಡಬೇಡ, then we'll move on to problems. Okay, yeah, so first Resolving ಅಂದ್ರೇನು? Splitting of a given vector into two components. You can resolve the vectors into components in any direction, but ನಮಗೆ help ಜಾಸ್ತಿ ಯಾವ್ದಾಗುತ್ತೆ? When we resolve them into rectangular components. ಅಂದ್ರೆ when we resolve them along the two perpendicular direction. So two perpendicular direction ಅಂದ್ರೆ ಕಾಮನ್ ಆಗಿ ನಾವು ಯಾವ್ದು ಯೂಸ್ ಮಾಡ್ತೀವಿ? X axis ಮತ್ತೆ Y axis ನ ತಗೊಂಡಿರ್ತೀವಿ. Okay, so ಇಲ್ಲಿ our vector A vector is there. So we can write this A vector as something like AX vector plus AY vector ಅಂತ ಬರಿಬಹುದು. But AX vector ಅಂದ್ರೇನು? The magnitude along X direction into the unit vector. Unit vector along X axis is I cap. So we can just rewrite this as A vector is equals to magnitude, that is AX into I cap, and AY vector andrenu? Magnitude of AY into J cap. Okay, so illi theta is the angle enide between A vector and X axis ide. So this component will be A cos theta agirutte. This component will be A sin theta agirutte. Okay, or in other words, this AY will be equal to A sin theta. Okay, so theta attach agiro side cos component agirutte yavaglu. So illi enide theta illide, right? So adakke attach agiro resolving side enagirutte? Cos agirutte. So adakke perpendicular iro side sin agirutte. So we can say our AX is equals to A cos theta and AY is equals to A sin theta. And ಇದನ್ನ ನೀವು ಸ್ಕ್ವೇರ್ ಮಾಡಿ ಆಡ್ ಮಾಡಿದ್ರೆ you get the magnitude of the vector A. So magnitude ಅನ್ನ ಹೆಂಗ್ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಬಹುದು? 2 ಮಾಡ್ಯುಲಸ್ ಬರ್ದು ಅದರೊಳಗಡೆ ವೆಕ್ಟರ್ ಬರ್ದ್ರೆ that is nothing but the magnitude of vector A, or simply without the arrow ಬರ್ದು it is understood it is magnitude. So A is equals to ಏನಾಗಿರುತ್ತೆ? Square root of AX square plus AY square. Okay, magnitude of the vector also you will get from this, that is magnitude of vector A is equals to square root of AX square plus AY square agirutte. Okay, or full vector na heng represent ಮಾಡಬಹುದಾಗ our total A vector is equals to A cos theta into I cap plus A sin theta into J cap agirutte. Okay, so please remember theta attach agiruttalla, that will be our cos component bandirutte. Innondu perpendicular direction sin bandirutte. Okay, and sometimes we call this along x axis idella, idana horizontal component anta karitivi. AY, that is along the vertical direction iruttalla, adana vertical component of the given vector agirutte. Okay, any doubt? Yeah, so what I will do is these two concepts I'll just discuss in the next class, that is how to represent the resolved components in 3 dimensions, that we'll discuss in the next class, and representation of position vector and displacement vector also. So now we'll take up some problems. A force of 5 Newton on a particle acts on a particle along a direction making an angle of 60 degree with the vertical. Its vertical component will be, okay, so in kottidare we are given with a force, okay, and our force enagide, this is making 60 degree with the vertical anta kottidare. Okay, this is the force vector of 5 Newton, and with the vertical it is making 60 degree. Okay, this is our x axis, this is our y axis. So all of you can try to solve this problem quickly. So we are supposed to find out the vertical component, andre Fy anta ತಗೊಳ್ಬಹುದು, the component of force along the vertical direction. So ಇಲ್ಲಿ ಎರಡು ವೇ ಆಗಿ ಮಾಡಬಹುದು. If this is 60 degree, you know that this will be 30 degree. I call this as theta. So eega if I call this angle as theta, this component will be f cos theta and vertical component will be f sin theta. So we want fy is equals to, that is f sin 60 degree alva, sorry 30 degree. Okay, so f value ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ 5 Newton ಅಂತ ಇದೆ and sin 30 value ಎಷ್ಟು half. So this is going to give you fy is equals to 5/2, which is nothing but 2.5 Newtons. So that is option D is the correct answer. Is that fine? Yeah, hope you are following. So ಇಲ್ಲಿ clear ಆಗಿರಬೇಕು. Theta, either you had to know that you had to define theta with respect to x-axis. ಆಗ cos theta will be along x-axis, sin theta will be along y-axis ಆಗಿರುತ್ತೆ. If you take this, okay, 60 degree ಅಂತ ಕೊಟ್ಟಿದಾರಲ್ಲ, ಇದನ್ನ ನೀವು ತಗೊಂಡ್ರೆ, let me call this as something like alpha ಅಂತ ತಗೊಂತೀನಿ. ಸೊ ಆ ಕೇಸ್ ತಗೊಂಡ್ರೆ ಏನಾಗುತ್ತೆ, ಸೊ ಇಲ್ಲಿ ಕೇರ್ಫುಲ್ ಆಗಿರಬೇಕು. ಫಾರ್ ಆಲ್ಫಾ ಆಗ ಹೆಂಗಾಗಿರುತ್ತೆ, ಎಫ್ ವೈ ವಿಲ್ ಬಿ ಈಕ್ವಲ್ ಟು ಎಫ್ ಕಾಸ್ ಆಲ್ಫಾ ಆಗುತ್ತೆ ಅಂಡ್ ಎಫ್ ಎಕ್ಸ್ ವಿಲ್ ಬಿ ಈಕ್ವಲ್ ಟು ಎಫ್ ಸೈನ್ ಆಲ್ಫಾ ಆಗಿರುತ್ತೆ. ಓಕೆ, ಸೊ ಕೇರ್ಫುಲ್ ಆಗಿರಬೇಕು. ಆನ್ಸರ್ ಸೇಮೇ ಬರುತ್ತೆ, ನೀವು ಮಿಸ್ಟೇಕ್ ಮಾಡಬಾರ್ದಷ್ಟೇ. ಸೊ ಎಫ್ ಅಂದ್ರೆ ಅಗೈನ್ 5 into cos 60, correct, and f sin alpha antide, that is 5 into sin 60. Okay, so this is going to give me, okay, let me just write here itself. So ಏನಾಗುತ್ತೆ ಈ ಕೇಸಲ್ಲಿ fy is equals to 5 into cos 60 andre again half, which is going to give you 2.5 Newton, and ಇನ್ನೊಂದು ಕಾಂಪೊನೆಂಟ್ ಟ್ರೈ ಮಾಡಿದ್ರೆ ಅಲ್ಲೇನು ಬರುತ್ತೆ, so this will be equal to 5 into sin 60 is √3/2. Okay, so this is how you solve. Is that clear? Hope it is fine. You can go to next question. Any doubts in this? Yeah, this problem, after discussing 3-dimension representation of a vector, adadmel martini. Okay, it's a very simple one, but ali vector notation 3-dimensional ide, I j k notation ide, so that we'll discuss later. Yeah, this one we can take for now. The x and y components of a force F acting at 30 degree to x axis. So in kottidare again, be careful here. So there is a force F which is acting at an angle of 30 degree to x axis anta kottidare. So ಇಲ್ಲಿ ಏನು ಕನ್ಫ್ಯೂಷನ್ ಆಗಲ್ಲ, ಇಟ್ ಈಸ್ ಅವರ್ ನಾರ್ಮಲ್ ಡಿರೈವೇಶನ್ ಅಲ್ಲಿ ಹೆಂಗ್ ಮಾಡಿದ್ವೋ ಹಂಗೆಯ. ಸೊ ಕಾಂಪೊನೆಂಟ್ ಅಲಾಂಗ್ ಎಕ್ಸ್ ಅಂಡ್ ವೈ ಬೇಕು. ಸೊ ಎಫ್ ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಎಫ್ ಕಾಸ್ 30 ಆಗಿರುತ್ತೆ ಅಂಡ್ ಎಫ್ ವೈ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಎಫ್ ಸೈನ್ 30 ಆಗಿರುತ್ತೆ. ಸೊ ಕಾಸ್ 30 ಅಂದ್ರೆ cos 30 is √3/2, so √3/2 f, and sin 30 andre half, that is f/2 agutte. Okay, so component along x axis is √3/2 f and component along y axis is half f. Okay, hope it is clear. Any doubts? If there are, ಏನ್ ಡೌಟ್ ಅಪ್ಪ ಸಾಯಿರಾಜ್, ಡೌಟ್ಸ್ ಇದ್ರೆ ಕೇಳಿ. ಸೊ ಇಲ್ಲಿ ರಿಮೈನಿಂಗ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇದೆ, ಅದನ್ನ ನಾನು ಎನಿವೆ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀನಿ. ಎನಿ ಡೌಟ್ಸ್? ಸೊ ಐ ಥಿಂಕ್ ದ ಟೈಮ್ ಈಸ್ ಆಲ್ಮೋಸ್ಟ್ ಡನ್. Yeah, I had to end the session as the time is up. So if you have doubts, feel free to ask in the chat box, or you can ask in the next session as well. Okay, thanks for your response, Kirtana. So thank you all.